Hello viewers, welcome to this fascinating world of digital computers. Every one of us knows that today computers are digital and that they use binary numbers. You probably have some idea of what these terms mean, but we need to be clear about their precise meaning and to be clear about why computers are digital. So, in this lecture, we shall discuss about the binary signals, analog signals, advantages of binary bits, what are noisy signals. Viewers, if you want to know what is really going on with computers, study these topics carefully. Computers use strings of bits to represent all the different types of data that they have to work with. Data representation refers to the methods used internally to represent information stored in a computer. Computers store lots of different types of information like numbers, text, graphics of many varieties which includes stills, videos and animations, and your audio. At least these all seems different to us. However, all types of information stored in a computer are stored internally in the same simple format, that is a sequence of 0 and 1s. Now the question is, how can a sequence of zeros and ones represent things as diverse as your photograph, your favorite song, a recent movie or your semester paper? It all depends on how we interpret the information. Computers use numeric codes to represent all the information they store. These codes are similar to those you may have used as a child to encrypt secret notes, like 1 stands for A, 2 stands for B, etc. With this code, any written message can be represented numerically. The codes used by computers are a bit more sophisticated and they are based on binary numbers instead of more familiar decimal system. Computers use a variety of different codes. Some are used for numbers, others for text and stills, others for sound and graphics. A computer system is made up of electronic circuits. These circuits carry two states, a low and a high charge. Manipulating these charges so that they can do something of use is what the computer does. The binary number system is well suited for this manipulation because it is a two-state number system. It can be used as a model of the computer's circuits with a 0 representing a low charge and 1 as a high charge. By manipulating the circuits of the computer system to behave like a binary number system, the computer is able to perform calculation the basis of all its operations. Other number systems can be used, but the difficulty of creating more than two states make them impractical. We know that binary means two states. The two states are sometimes called 1 and 0, or can be called as true and false, or can be called as off and on. The essential characteristic is that a single binary device can be in just one of the two possible states, that is either on or off. A bit is a single on or off value. A good example is a toggle switch such as a light switch. You can either turn it on or off, but not anything else. A light switch holds one bit of information. A light dimmer is not a binary device. It has many positions between off and on. If you want a light dimmer to be set to 25%, you must carefully adjust it. Now the question is, why computers use binary numbers? This can be explained with the example of an ignition switch. The ignition switch of an automobile is discrete, that is, it has definite states. But there are usually more than two states, like the vehicle can be in off state or in a running state or is still accelerating. A button on a hand calculator is a binary device. It is either on or off. Ordinarily, it is off. When you push it, it is on. It springs back to off state when you release it. which is different from a toggle switch, but it is still a binary device. There are many advantages to binary. Here are 4 somewhat overlapping the important reasons for using binary. First is simple to build. Second is unambiguous signals, that is noise immunity. Third, flawless copies can be made. Fourth, anything that can be represented with some sort of patterns can be represented with patterns of bits. Claude Shannon, a mathematician at Bell Telephone Laboratories, realized these characteristics of binary. His paper, A Mathematical Theory of Communication, is the foundation of information theory and much of computer science. Coming on to the advantages of binary, first one is simple, that is easy to build. An on-off switch is simple and easy to build. An on-off switch moves 2 pieces of metal together or moves them apart. A light dimmer must gradually and smoothly change the current that reaches the light. It has more components than an on-off switch and must be carefully assembled. An accurate dimmer, where 25% means exactly 25, is even harder to build. The same is true for the tiny devices inside a silicon chip. On-off switches are relatively easy to fabricate. Easy to build means that the devices are cheap, small and reliable, and millions of them can be put in small area. Now, second advantage of binary is unambiguous signals. Carving a block of wood into a book page requires high technical and artistic skills. The task is complex and labor intensive. A small mistake might ruin the whole block. Setting type is comparatively easy. Little artistic or technical skill is needed. Individual pieces of type are just dropped into place. The method is robust and reliable, that is, mistakes can be corrected. The type can be reused many times. It is a paradox that advances in technology often lead to simple methods. Wood carving is complex. Setting type is easy. The computer revolution, that is from circa 1950, is often compared to Gutenberg revolution, that is circa 1450. What are unambiguous signals? Consider Paul waiting for news of attack of the British troops. He is expecting to see a signal lantern in tower of old church telling him how the Britishers are attacking. 1.3456 if by land, 1.7192 if by sea. The signal shines out and the Paul famous ride is delayed for several hours as he tries to figure out just how bright that signal is. Lack of ambiguity is tremendous advantage. The signal that Paul was actually waiting for that night in 1775 was 1 lantern if by land and 2 by sea. Before learning about what actually unambiguous means, we have to discuss about what actually is a discrete signal. The signals are called discrete as they have fixed number of definite states. Sometimes the word digital is used to mean the same thing. Now, what is an analog signal? An analog signal may continuously change in value. Its values can be anything within a range of values and its exact value at any time is important. The graph on the screen represents an analog signal. The exact value at each time is part of the information it contains. For example, the value at time t2 must be measured exactly. Now, say that you are observing the voltage of a wire. It has been agreed that any voltage below a threshold will be counted as an off signal and that any value above the threshold will be counted as on signal. Coming on to binary signal, analog signals continuously change in values. By using a threshold, analog signals can represent binary data, that is on or off data. It is easy and fast for humans as well as for electronics also to determine if a voltage is above or below a threshold. The figure shows a signal that transmits off then on. That is, the signal is examined at times t1 and t2. The ons and offs of the previous signals are clear, but what if the signal is sent down a long wire and someone nearby turns a vacuum cleaner? The whirling and sparking electric motor creates a great deal of electrical noise. The graph shows the signal at the other end of the wire. Even though the signal is noisy, that is at analog level, the binary values are transmitted perfectly. You and the electronics can still tell that at time t1 the signal transmits off and that at time t2 the signal represent on state. The receiving end just needs to get the binary values. Since only the on-off information matters, the analog noise is irrelevant and the original signal is received perfectly so far as the binary information goes. Third advantage of binary is flawless copies can be made. The receiving end of the signal is only interested in the binary values. All it has to do is check if the signal is above or below the threshold. This can be done perfectly as long as the noise is not too great. For example, here is the noisy signal with off and on values recovered from it. The original signal has been recovered flawlessly. This process can occur as many times as needed with a perfect copy made each time. This is essential in computer system where bit patterns, that is pattern of 1 and 0 or on and off, are copied back and forth between processor and memory millions of times a second. The copies have to be perfect. Digital systems are built so that the value is only tested at certain times, giving the wire a chance to change its state between these times. This is why computer systems have a clock, that is to keep all the times synchronized. So, faster clock means wires can be tested more times per second and the whole system runs faster. Processor chips and the computer that contains them are often described in terms of their clock speed. Clock speed is measured in hertz, where 1 hertz is 1 clock tick per second. The symbol megahertz means megahertz, a million clock ticks per second. A 1 gigahertz processor checks binary values 1000 million times in each second. In between these times, values are allowed to change and settle down. The faster a processor chip is, the more times per second values can be tested and the more decision per second can be made. Coming on to fourth advantage, representing anything. Recall that last advantage of binary. Anything that can be represented with patterns can be represented with patterns of bits. Since data of all kinds is stored in computer memory, that is main and secondary memory, using the same electronic methods, this means that endless perfect copies can be made of any type of data or program. The idea is that any system of symbols can be translated into bit patterns. An example is how English characters are represented as 8-bit patterns. The agreement about what patterns represent what characters is called a sky. The hardware and the software of a computer system follow this agreement when the data is text. You will learn more about this later. Other types of data, that is non-character data, are represented using other methods. More on representing anything in binary Indian language characters also have been translated into bit patterns, and the computers can manipulate those symbols just as easily as a sky. Unicode is an agreement created by an international committee on how to represent characters using 16 bits. Here are 16 bits: 111100, 11111110, and here is the character it represents in Unicode. Say that international committee decides to represent a new Hindi character. How can they do this? That is easy. They find a bit pattern not yet used to represent any symbol and assign the new character to that pattern. The correspondence between human language symbols and bit patterns is arbitrary. All you have to do is be sure that you are using enough bits so that each symbol of the language has a unique bit pattern to represent it. Now, what are symbols and patterns? Recall that last advantage of binary. Anything that can be represented with patterns can be represented with patterns of bits. What about representing things other than written characters of a language? This is a deep topic and entire books have been written on it. Here is very sloppy discussion. Pick some subject, use English sentences to describe it, represent those sentences in ASCII, that is characters encoded as bit patterns. Now, the subject is represented in binary. If something can be represented in English, then it can be represented in binary also. Notice that this says nothing about meaning or understanding. Printed books do not understand their own content. A digital version of book does not understand the book either. It merely holds the information waiting for a human mind to do the understanding. However, the book has been represented as bit patterns. Nobody said that binary representation are easy to use. Some representation methods are very useful for computers, for instance, using binary patterns to represent numbers. Others are nearly useless. Much of the work that computer scientists do is figuring out how to represent things using binary in ways that are useful. For example, much work has been done in last 10 years in figuring out how best to represent image and audio data. Viewers, at this juncture of time, I like to make an important point. All that computer memory holds is bit patterns. What those bit patterns represent depends on how they are used. Thanks for watching this lecture.